In this example, we are looking at a ladder leaning against a wall. So here is the wall, and then here's the ladder on the diagonal because it's leaning. We can make a nice right triangle out of this. It's telling us the ladder is 41 feet. I'm also going to give this a letter in case we need that at some point later. And the top is sliding down the wall. So we're going to call this Y, we're going to call this X. And we might actually be able to come up with information about the X and Y based off of that. So we know so far the ladder, or the S, is 41 feet. It's sliding down the wall, or sliding away from the wall at 4 feet per second. So because it's going away from the wall at 4 feet per second, that's the X. So that's giving us dx over dt is 4 feet per second. And then the first question asks, how fast is the top sliding when it is 9 feet above the ground? So the 9 feet is giving us our Y value. And since we actually, because 9 now is on our side here, we can use Pythagorean theorem to find our Y value. I think I said Y, I meant to say X. Our X value will come out to be 40 feet. So we have a lot of information we'll be able to plug in. And the question is asking how fast is the top sliding. That's going to be our Y rate. So dy over dt is our question mark here. So when we set up this equation, we're going to use Pythagorean theorem again. We want to keep x and y in there because those are things we can plug in later. We have information for dx over dt. We're trying to find the dy. So we want both of those variables still in our formula. The one variable that we can plug in is the s. And the reason we can do that is the ladder length is constant. That's not going to change, even though as it's sliding down the wall, the distance up the wall and away from the wall will change. All right, so we can use this formula to take our derivative. We'll do 2x dx over dt plus 2y dy over dt. Remember, for every variable, you're going to put that information, and then the derivative of a number is 0. And now we are able to plug in most of the stuff. We know that x is 40, dx over dt is 4, we know that y is 9, and then we're solving for dy over dt. So we don't have anything to plug into that, but we need some sort of variable left to solve for. So that's going to give us 320 plus 18y, or 18 dy over dt is equal to 0. And then again, I'm going to put this as exact and approximate, so we could do negative 160 over 9 feet per second, or negative 17.78 feet per second. Now part B asks us, and we actually have enough information to just set this up and solve now because we have all of our rates. It wants the rate which the area is changing. So I didn't scroll back up to get these formulas because I feel like you're pretty familiar with them. So area of a triangle is 1/2 base times height. In this case, will be 1/2 x times y. The only issue with this derivative is its product rule. So when we do dA over dt, which is what we're solving for, the rate of the area, we'll do first, so 1/2 x times derivative of the second, so dy over dt, plus second, so y, times derivative of the first, so 1/2, and that will be dx over dt. And again, we have enough information to plug everything in, so we're going to just be solving for that area rate, 1/2 times 40 times negative 160 over 9. I'm going to put in the exact because we had dy over dt. We solved for that, plus 9 times 1/2, and dx over dt is 4. And then if you calculate that rate, you get negative 337.56. It's area, so we'll do feet squared per second. So the area is decreasing by 337.56 feet squared per second. And then the rate that the ladder is sliding down the wall is at negative 17.78 feet per second.